Hi class, happy Wednesday. Today we are actually going to jump ahead and look at section 2.4. As I talked about before I left, we're going to skip 2.3 for now. We'll come back to it when I'm back. 2.3 tends to be a little more tricky for students, while 2.4, you can see by the title, we're just going to look at the graph of y equals kx. The reason this falls under or after direct and inverse variation is because it is a direct variation example, but it is just y equals kx to the first power, so it's about as basic as we can get. Before we get into just talking specifically about y equals k times x, we're going to first review slope-intercept form. As we can recall, slope-intercept form is y equals mx plus b, where the slope is the m and the b is the y-intercept. So that's just a review of what we know about slope and y-intercept and the slope-intercept form. The reason I talk about this today is because if we talk about this equation we're going to look at, y equals kx, you can see that it actually kind of follows this, except the y-intercept would just be 0, and k, our constant of variation, is going to be the slope. So y equals kx will be a line. The key is it's always going to go through 0, 0, because the y-intercept is 0. And once again, the slope will be k. That's the constant rate of change. So this shouldn't be too tricky if you understood slope-intercept form from previous years. So let's move ahead. We are going to review how we can find the slope of a line. There's actually 5 different ways we're going to talk about it, but 3 in particular we're going to focus on. First of all, we're focusing on if we're given 2 points, so we'll call them x1, y1, and x2, y2. So if I'm given those 2 points, the algebraic way to find slope is m equals y2 minus y1 over x2 minus x1. So hopefully you've done quite a bit of work with that. The most common way I usually hear students say they think of slope is that slope equals rise over run. That's another way to think about it. And the more common way you want to think about it as you head into higher levels of math is that what slope actually is. And slope is the rate of change. Okay, so these are 3 ways we'll think about slope regularly. The first one's the algebraic way to think about it. The second one, rise over run, is more from a graph, how we would think about it, and the rate of change is actually what's happening. Now there are a couple of different ways, you can write these down or not, but a couple of other ways to think about it. You don't have to write them down, but change in y's, if you think about the coordinate grid, the y-axis is the vertical axis, right? So if we think about that and the fact that the change in y's, or y2 minus y1, goes on top, another way to think about that would be that it's the change in the vertical distance. So that's another way to think about rise over, and then the run would be along the x-axis. So that would be change in horizontal distance. So again, just another way to think about the same thing. And finally, we could think about it, if we're thinking about x's and y's as independent and dependent variables, the y is always the dependent variable, so another way to think about slope would be the change of the dependent variable which again would usually be our y over the change of the independent variable. Which would be my x value. Now that we've reviewed slope a little bit, let's do a few examples. Again, I would encourage you to pause this and try them on your own first, and then see if you get them right. But if we want to find the slope between 2 points, again, I'm going to take m equals y2 minus y1. So if I define this as y2, this would be y1. So I have -4 minus 5 if this is y2, I need to use this as my x2, and I need to put that one first as well. And then the 2 would be x1. Sorry about that. Negative 4 minus 5 is a negative 9. 3 minus 2 is 1. So my slope in this situation would be negative 9. For this one, just for the sake of knowing that it doesn't really matter which ordered pair you pick, if I pick this as x2, y2, this just would have to be x1, y1. So you just have to be consistent. If you did 5 first, that's totally fine. You should get the same answer. But if I did negative 3 minus 5, I would just have to do then negative 1 minus 3. Get negative 8 over negative 4, and negative divided by negative is positive, and 8 divided by 4 is 2. Okay, so given 2 points, that's a review of that. Another way to think about it, now remember this is an example of y equals kx. It's a straight line and kx is linear, and then you can see that it does go through the point 0, 0. As a result, it is an example of the type of equation we're looking at. And if I want to find the slope of this, I could have labeled my axes here, but basically you need 2 points. It looks like it rises by 1 and runs by 2. So if I found my slope, it's rise over run. Again, the rise I went up by 1, the run I went over by 2. So my slope with this line would be 1/2. Again, hopefully all this is review. So let's generalize what we know about slopes from the past. First of all, a positive slope. If I was going to graph that in the coordinate grid, all positive slopes go this direction. Okay? As a review, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if we're specifically talking about y equals kx, any y equals kx equation that has a positive k value or positive slope would go in quadrants 1 and 3 because it's always going to go through 0, 0. If it had a negative slope, it would switch directions. It would go this way. And in this situation, if we're talking about y equals kx, so again, assuming it goes through 0, 0, then that line would always hit quadrants 2 and 4. The larger the slope, the steeper the line. Okay, so the larger the slope gets, the steeper the line. For example, if I have a slope of 2, it could look something like this, whereas a slope of 1/2 would start to get flatter. Okay, so that's where the small slopes get more flat. Okay, and then again, this example shows both those scenarios. So in general, those are just some of the key things you need to know about slope and the y equals kx equation. Again, I told you there won't be much new today. That's pretty much it. This would be the type of problem you'd be expected to be able to do. You'd want to be able to complete the table of values and then graph the variation equation. So again, I would pause it, take a minute and do that, and then look at your work. So when I do my work for this, for the first one, I'm going to do 2 times negative 4. So it's negative 8. Fill that in. I'll do y equals 2 times negative 2. Gives me negative 4. Fill that in. Y equals 2 times 0. As we know, anything times 0 is 0. Y equals 2 times 2. That's 4. And y equals 2 times 4. That's 8. If I go to graph these ordered pairs, I go back 1, 2, 3, 4. So this is negative 4. Go down 8. 1, 2, 3, 4, 5, 6, 7, 8, 6, negative 8. So I'd have a point over here. I'd have a point at negative 2, negative 4, point at 0, 0, which makes sense because we said k times x. So we'd always have that. Point at 2, 1, 2, 3, 4, 5, 6, 7, 8. Thinking ahead. So 2, 4, and 4, 8. So I can take those 5 points, graph them, try to draw a straight line through them. And there is my equation, my line. Again, because the slope is 2, it's a little bit steeper. Goes through the value 0, 0. Because it has a positive slope, it did end up in quadrants 1 and 3. And that's about all you need to know for that. So now you should work on completing the Lesson Master worksheet that I gave you as well, and have that done by tomorrow. I will be back on Thursday, so when I return, you should have watched the videos for 2.1, 2.2, and 2.4 and have the notes on those. You should also have a worksheet, 1 page front and back from each day completed. I will check those Thursday when I get back, and we'll review some of this stuff and then start looking at 2.3. Thanks a lot, and enjoy the rest of your day.